Welcome everybody to another installation of the Works Plus TechTalk podcast, where we talk about all things polished concrete. Today I have a grandfather of the industry. This is a visual thing. Tim Van Der Veen, and we are going to be discussing matters such as fully exposed polished concrete versus surface polished concrete, the major differences, not just aesthetically, but mechanically and chemically. So I'm expecting on the other side of this podcast, we're all going to be experts.
And I'm expecting to rename myself as Grand Der Veen.
Everyone already calls you that behind your back, Tim.
But update the business card.
Thank you for taking some time out. Now, Tim, you spend a massive amount of time these days in the R&D department and coming up with ideas, testing ideas day in, day out. And you've probably got more information and experience on the topic that we're going to be talking about today than I think anyone else does. Hence, I thought we'd sit here and pick your brain for half an hour to an hour, and the rest of it we'll just talk crap.
Well, all right. There's actually no new ideas, Josh. I'm just retesting the old ones over and over.
That's why we're going to start with the history. She seemed best poised for it. Uh-huh. So I want to go back really, really briefly before getting into it, into this, I guess, the comparison between the two. But if we're to compare, I guess, the Northern Hemisphere to the Southern Hemisphere, it seems like there's a big difference in expectations from polished concrete. And I just want to set the tone for that before we kick off and then get into I guess, some of the nuances on the definitions, and then talk about the practical implications of the said differences. So let's go back to late 90s, early 2000s, and there's this whole thing kicking off called polished concrete. Say we just kicked over a millennium. What is polished concrete scene looking like at that time?
Well, I think really the way it kind of started was we were doing just floor preparation back then, and we'd grind a coating or an adhesive or something off a floor, and we would do that fairly aggressively because we wanted to get in and out of the place. And there would be all of a sudden exposed aggregate on the floor, and we'd have clients that would basically say, "Oh, can we put like a lacquer or something on that and just leave it as it is?" Right?
It's kind of making me feel sick.
And we said, "Sure." And so we just started literally putting a polyurethane single pack solvent-based product down over floors. And that was really what we'd call polished concrete back then. It was a grind, 2-3 steps to refine the surface a bit, still have an adequate adhesion for a topical coating, and it was polished concrete in a can. Which is nowadays what the market here calls grind and seal. But that was the term back then. That was polished concrete. There was no other type.
Yeah, okay. So people started off already seeing exposed aggregate and went, maybe we could do something extra with that.
Yep.
What was the next phase after that? I mean, we didn't go straight from polished concrete in a can to, beautiful exposed aggregate, hard and durable mechanically polished surfaces, did we?
No, I think it was something in between, because clearly our experience before the polished concrete in a can was actually the terrazzo grinding. So we had a background of, let's call it semi-polishing terrazzo floors. We would take that to what we could probably say is a 200 resin finish these days. So we were already mechanically polishing terrazzo to a higher level, and then the grind and seal, or the polished concrete as they call it back then, was quite a step back. So we had already the experience of taking terrazzo up to that sort of 200 finish, and then applying like a water-based acrylic coating, give it a burnish with a high-speed burnisher. That's how we got that last gloss and shine and obviously seal on the floor. And I think from memory, our next iteration to polished concrete was something more like that. We started taking it to a higher gloss, a little bit smoother, and then hitting it with a water-based acrylic, because we wanted to get away from the roller coat looking texture finish from a polyurethane, plus obviously high solvent sort of content product didn't work in a lot of environments because a lot of these places were refurbs in trading shopping centres and things like that where they just couldn't take the smell. So I think our next iteration was probably more a bit of a step back to the terrazzo days, but applying those principles to concrete. And we obviously liked that a whole lot better because we were actually turning that material, that concrete, into a much better finished product because we came from a finishing trade and we kind of saw that grind and seal more a demolition type process.
Yep.
And it just didn't turn us on the way that terrazzo did. So we kind of saw an opportunity to turn the concrete more into the terrazzo that we sort of cut our teeth on.
A bit more refined.
Yep.
Okay, so then after that, is that where mechanically polished concrete came in?
I think it was, but I think you'll remember we had quite a resistance to mechanical polished concrete in the early days because there was a whole lot of promises about it. It was being oversold in the marketplace, both here and in the States, where it sort of took off a little bit quicker. A lot of the properties and a lot of, I guess, the performance criteria that were being claimed it would do, just we were doing tests, we were trying it out, and it just wasn't stacking up. I remember it was being sold as the bulletproof floor that once you had densified and polished these floors up to a certain level, that they just weren't going anywhere, that there was nothing that could touch them.
Yep.
And I remember we pulled out our lightest weight single phase grinder at the time to a rep that was peddling some of the chemicals for it. We did the mechanical polish by his spec or through the process, and he said that's forever now. That's not going anywhere. So we pulled out their lightest weight machine with a set of diamonds, and we just ground it straight off again, and the smile just vanished off the face. And I think for us it was kind of like, well, this doesn't seem to be fitting the bill. So it doesn't seem to be living up to the hype or the expectations that were being promoted in the marketplace. And I think it was understandable because people could see the opportunity or the possibility of what to do with this material, but it just wasn't being achieved. And so we kind of fell back to, hey, we kind of think the old way that we were doing it was still superior. It was an easier process and a faster process for us at the time. So
which one's that?
Either of them, the grind and seal, or that, let's call it that hybrid system where we were semi-polishing and putting down that acrylic coating. We could do that faster. We saw it having a higher lifetime or abrasion resistance, durability compared to this new sort of completely mechanical finish that was being promoted that wasn't really that well understood. So there was a bit of resistance from us. And
I could imagine as well, like, I mean, the rep says that's permanent, that's forever floor. Mm-hmm. And your background was not in epoxy terrazzo, it was in cementitious terrazzo, which is a material that's been mechanically densified by compression in the factory as a tile and then installed. So that's a really hard material that you're used to working with.
Yeah, so not an in situ terrazzo, like you're saying, pressed tiles manufactured off-site. Yep.
Yeah, so you've already got this idea in your head of what a hard and durable surface is, and then the rep's gone, well, that's forever, and you've just gone, well, that's actually easier to cut than the terrazzo material I'm used to cutting every day.
Pretty much. Yep. So yeah, we were resistant, and look, I guess the resistance came from the fact that we were predominantly a contracting business back then, and we had to sell a product. We had to sell a product that we actually felt like we could stand behind, and that we were going to be able to hold warranties on and support going forward.
Yep.
And we knew what we knew, and we knew how to do that. This was a whole new sort of ball game, which in the infancy didn't look like it was ticking the boxes that we needed it to tick for our clients at the time.
Yep. Okay. So then we've talked in a couple of previous episodes of then what happened in the contracting business. There was the overlay product designacrete, which was a veneer essentially, and some of these concepts were tried on that. That was a part of the hybrid system, which had a acrylic sealer on the top as a finishing product. And some tests were done on that to try and introduce densifiers and that type of thing, which were not compatible in that original platform. But what we were getting was great results on the concrete formulations with the densifiers and, of course, the complementing abrasives. And so when we had Gary from Mentone, we talked about some of the introduction to polished concrete in Australia, particularly in Melbourne, was in specialised architectural mixes. And that was all exposed aggregate, because I guess it was sold that way. People were going to Mentone and picking out the colours of the cement and the matrix and of course the aggregate. So that was kind of the value that you're buying. But in the Northern Hemisphere, something else was very different. I mean, obviously they were selling a solution to a different problem. The problem up there, I guess you could say, was more in the industrial space. Is that correct?
In the States, industrial and large retail.
Okay, so that was what we were seeing as a major difference between the northern and southern hemispheres, was that everything in the southern hemisphere, I mean, whether it was grind and seal, it was getting ground back, and that was exposed in the aggregates, just typically by the nature of it was happening in old retail, refurbished floors, getting a polyurethane down, or getting, I guess, the hybrid system that sat in between there, a bit more refinement and an acrylic sealer on top of that. Or then we had the next phase, which was the installed floors, or the infill slabs with decorative concrete, and of course people wanted to see the aggregate. Going to the Northern Hemisphere, that's kind of different. They're doing large format retail and they're doing industrial spaces. No one's really promoting, hey, you want to see all the aggregate here. So I think what we've got there is a pretty good test bed between two different types of technologies for finishing and two different types of flooring systems. In the Northern Hemisphere, we're seeing a lot of surface polishing happening. And in the Southern Hemisphere, we're seeing exposed aggregate. And they've both been around for more than 20 years now in many cases. So we've been able to gather a ton of data on how these actually stack up. So for the purpose of this podcast, I'm going to call the Southern Hemisphere exposed aggregate MPC. That's a mechanical polishing system. And then for the Northern Hemisphere, which is, we're starting to see a lot of it down here over the last 5, 6, 7 years, I'm going to just go with the surface polished mechanical system. So we call that SPC, surface polished concrete.
I thought you were going to go on the North versus South theme again.
I'm trying not to create any division here. There's a lot of alliances that our governments have worked on for a long time, and I don't want to get in between any of that. No more tariffs, thank you, Trump.
And we know he's listening.
Yes, Uncle Donald.
He tunes in every episode,
every podcast. Yes, yeah. So let's talk about some of the, I guess, the defining differences between those two types of systems, I'm going to call them. What's happening? What are our major visual differences? What are our major differences for how these two different systems are put together? And then we'll talk about some of the life cycle impacts and that sort of stuff.
Yeah, okay. Well, I guess one of the main components is we're talking about a piece of concrete, okay? And it doesn't matter whether it's a 4, 5 inch, 6 inch piece of concrete, they pretty much will, in the types of environments we're talking about, go down the same, right? And it's quite interesting because if you look at a concrete slab, you could say, in a let's say a 4-inch concrete slab, 95% of it is the same, and 5% of it's different.
Which 5% is different?
And that 5% is the top side, right?
Yeah, okay.
The top of the slab. And it's different. It's not different necessarily from a recipe point of view. It's the same concrete that came out of the agitator or the pump or whatever it is, but it's been handled or it's been finished different, and it's the only part of the concrete that comes in contact with a bunch of variables that the rest of the concrete doesn't.
Sure.
So you've got the air, you've got moisture, and humidity. You've got obviously the mechanical, whether it's trowel finished. It's where the bleed water comes to. It is a separate layer essentially to the rest of the body of the material. So even though it's all the same recipe at the batch plant and what comes out of the truck, just by the nature of it's got a top side that's exposed to an environment and other processes that the other 95% of the slab isn't, it's kind of different material.
It's kind of like the door on a house.
Yeah, in a sense. And we know this because, we've had crossovers with customers in this industry that are in the concrete cutting and drilling industry.
Yep.
And they would come to our seminars, particularly in the early days, and we would be talking about selecting diamond tools based on the surface of the concrete. And they'd go, why are you doing that, right? Because their experience was they're selecting the diamond tools of basically what's in the middle of the concrete, right? When they're down the aggregate, when they're in the Rio and that sort of stuff, right? They're setting their tool selection based on the 95% because that's what they're actually dealing with.
That's their biggest challenge.
That's their biggest part of the material that they're dealing with. And we're dealing with the 5%. So even our approach as contractors and operators in that the two different industries working with the same material was completely different.
Yep.
So it basically goes to say that there is a difference between the top of the concrete, that top 5%, that top 5-6 millimeters, whatever it is, and then the rest of the slab.
Yep.
So I think the key to a lot of what we're talking about comes back to even that principle itself regarding the concrete slab.
So then we're talking about the top 5-6% being different.
Yep.
Once we've removed that 5-6%,
yep,
the two different types of, I guess, the nature or the nature of those two different surfaces.
Yep.
Purely from a chemical perspective or chemistry perspective,
yep,
even from a mechanical perspective when we're selecting tooling and that sort of stuff.
Yep.
Same concrete, completely different approach as far as the way that they react to chemicals that you introduce, and as well as diamond tooling, how it's going to respond when grinding or polishing or honing that surface.
Yep. Well, there's an old adage, and that adage is structure governs function. Okay. So I think it's probably an engineering term originally. The structure of something will govern how it works or what it can do. So structure very much governs function, especially in the concrete space. And I guess if you explore, if we are going to say that top 5% of the concrete has a different characteristics, then we can make the presumption, or we can explore that based on, is it a different structure, right? If it's different structure, if its composition's different to, say, the other 95% of the concrete, then we're going to say most likely it's going to have a different function, or it's going to have a different function, or it's going to be capable of a function that the other one can't, or vice versa. They're going to have different functions because they have different structures. So I guess that's one of the key questions to ask. Do they have a different structure?
Do they have a different structure, Tim? Is there another key question I should be asking?
Well, I mean, you probably understand that one just as much as I do, Josh. But I think we've kind of alluded to the fact that when a concrete slab is placed, there are different factors that are going to influence that top 5%, and therefore we will end up with a different structure. to the rest of the 95% of the body of the slab that's essentially not touched, apart from maybe vibrating and so forth. So what is the difference in the structure of the concrete slab at the top, in the top 5% compared to the rest of it? And how did we get that? And therefore, if we understand that, how may that affect the outcomes of some of the things we're talking about when it comes to aesthetics and performance?
Yeah, okay. I didn't realize this podcast was going to get so deep. I thought we were going to be a lot more superficial. But you're obviously doing the Southern Hemisphere talk here. So it's going to be deep. So, gosh. So we've established that effectively we're dealing, if we're refinishing the surface area of surface versus exposed aggregate, we're dealing with two different animals.
I think they need to be considered as two different materials, because it's really a case of the top surface is missing some of the components or the ingredients that
of the rest of the floor,
bottom of.
Yep.
And in not compensating, but basically it's got more of some of the other materials that the other 95% of the concrete has. So it's lacking some, but it's kind of been compensated by ending up with a whole lot more of some of the ones, if that makes sense.
All right, so let's break that down a bit. If we're talking about the surface, it's got a whole lot more of what?
Well, let's probably just narrow this discussion to what we would consider an adequately finished concrete slab. So something that's been well troweled and so forth, as opposed to like a rain damaged slab or something just got a stipple finish or something.
Yeah, I think
because we're talking about that large format retail originally. They're highly troweled, sort of finished. So what's the difference? Well, predominantly you've got a lot more of the fine materials than you do in the rest of the concrete. So that troweling process brings more sands to the surface. It brings more cement to the surface. Obviously, we end up with all the bleed water coming to the surface as well. You've probably got all your fly ashes and your slags and so forth that are part of what's bulking out your concrete mix. Anything else you can think of that might be a higher concentration or percentage in the surface compared to below?
Mainly just cigarette butts.
Footprints.
But cigarette butts and footprints, the footprints don't tend to get a whole lot deeper. But so we've got a lot more of the finer materials sitting up on the surface. Yeah. And of course, even those they're in higher concentration, but the process of troweling has actually made them even more dense. So not only are they in higher concentration, but they're clumped harder together, compacted harder together. Yep. That's a really good way to describe that.
You'd call it that interparticular or interparticle space is smaller, even though the concrete's been vibrated. Okay, potentially, you're still going to get a far more compaction of those fine particles at the top.
Correct.
Yep. I think that's a really important thing to keep in mind.
Okay,
because that's going to play into some of the things we're going to talk about. What, tomorrow afternoon at this rate?
Well, I think it's really important to define the two materials as what they are and what we're working with.
Yep.
So I think we've kind of established that top layer, the way that we've got a higher concentration of the finer particles.
Yep.
What is the purpose of most of those finer particles that we see that have come to the top level? I mean, what purpose do they typically fulfill throughout the entire mix?
Well, I mean, concrete is a blend. I think the definition of concrete is something like the coming together. So it's that aggregation, it's that coming together of materials that you need all of them to make a concrete. Obviously, you've got your cement particles, and let's call it some of your more reactive materials that are there to help with the hardening and the strengthening and the curing, I guess, of the actual product. And you've got parts in there that are there for its mechanical strength.
Yep.
And then you've got parts in there to fill up all the gaps, because you've got this mix of aggregates, and your aggregate portion in your concrete is only X%.
Mm-hmm.
They don't fit all nicely together like a jigsaw puzzle. So they need particles and smaller blend of materials to sit in between them to fill those spaces, but also to create that overlap and interconnection across the actual concrete of all those particle sizes. That's where it's where a lot of its mechanical strength comes from as well. So they fall into a couple of different categories themselves. Are they chemically reactive and part of the process of giving the concrete its actual strength and hardness? And are they then part of making up the mechanical strength from a particle interlocking sort of function? And we know a lot of the finer particles that come to the top of the concrete are more to do with that chemical process. And the particles that are lower in the slab, below that top 5%, are there more for the mechanical strength of the concrete.
Okay. That's good to know.
And have less chemically reactive properties. So if you think about your aggregates, most of the aggregate that's used in concrete are inert or non-reactive type aggregates, okay? At least certainly comparative to your cements and fly ashes and all that kind of stuff. Okay.
Gee whiz, Tim, you've really done a lot of research before this podcast. I appreciate it.
And then, of course, we've got your additives, okay?
Yes.
Your plasticizers and all those kinds of things that can be thrown into concrete to reduce cement compound or make them go, accelerate curing. That kind of stuff's going to be coming to the surface
all the way
too,
to the top,
because that's a waterborne product.
Okay. So some of those things are also what operators see at the top surface when they're struggling to get, I guess, a result that they're used to seeing they may have seen on another slab. The material has changed, or the additives have changed, or the ratio of in the other slab that they're working on, and they'll see that those differences that they often are fighting against.
Yep.
The things that you can't actually see from the outside.
And then there could be a curing agent as well.
Yes.
Which again is just a topical thing.
Yeah.
It's only applied to that top 5% of the concrete. That's where it affects.
Yeah.
Okay. It's going to affect the whole slab from a moisture retention and hydration, and therefore curing time. But it's going to be one of those factors again on the surface that the contractor is going to be dealing with that they wouldn't be dealing with halfway down through the concrete, or even a quarter of the way or less.
So if we've got two sections of polish next to each other, we've got the SPC, the surface polish, on all part of the same pour.
Yep.
Surface polish, and we've got a deep aggregate exposure polish. Both gone up to, let's say, 1500 grit. Are these? So these are really different in nature, as far as not just aesthetically. They're very different from the materials that are going to be exposed to the surface,
composition,
plus the composition, and therefore, I guess the way that they react to certain chemicals and that sort of stuff. What are we going to see as contractors on the installation side? So I'm going to go through the contractor side, and then I'm going to go through the I guess the owner side. As a contractor, what are the major differences that we're going to see? And I don't want to get too much into how we would approach them. What are the major differences that we're going to see in the surface in working with those two different finishes? What type of battles, or what type of, I guess, just differences are we going to see with a deep cut, hone, polish, the chemical processes versus a surface polish?
It's a good question. The sorts of things that are coming to my mind are, one, if we're looking at a mechanical polishing concrete system that a lot of our listeners would be familiar with, we're talking about introduction of some sort of chemical treatments, predominantly densifiers, okay? So densifiers rely on a couple of different things, and that is obviously what they're reacting with in the concrete, but also how they're penetrating into the concrete. So that's going to be one of the things I'm thinking about. When we're talking about the difference between a mechanical finish, an exposed aggregate finish and a surface polish, well, the composition of the surface is going to be quite different. Once we're into an exposed aggregate scenario, we're talking 40 to 50% potentially of the whole surface of the concrete being comprised of a solid stone or an aggregate particle. Whereas when we're talking about a surface polish, we're talking about there's nothing there. So all of that space, that 40, 50% is now represented by a different material. So that's going to have an impact when it comes to the tooling and your tooling selection and how your tooling actually works. Because in one scenario, it's in contact with an aggregate and a stone for 50% of the surface it's touching, and the surface polish, it's 100% of fine particles.
Yeah. Okay. So, and I guess some of the things that probably in the southern hemisphere we're quite used to is, you've got 30 grit going straight down into the aggregate.
Yep.
And once you've established that that surface texture, it's really easy to then roll into all of the other grits because that texture just keeps those tools cutting really efficiently and effectively.
Yep.
A bit more of a challenge, I would imagine, going into a surface polish.
Yep.
And when you mention there's other contributing factors such as your additives.
Yep.
For your anti-shrinks, your anti-cracks, and that sort of stuff.
Yep.
They're generally polymer based, and then we've got curing compounds going down as well.
Yep.
And then we want to do the least amount of, damage to the surface, disrupt it the least with the tool, but it requires some texture there to try and get it to work. So I guess we've got those differences as far as an approach is concerned. In both scenarios, heat's going to be our biggest issue. Once we've overcome all of that, we've been able to install them. We've got a surface that the deep grind exposed aggregate has 50% or around 50% of aggregates exposed there.
Yep.
And then we've got sand and cement structure in between.
Yep.
We've got a really high level of a high level of cement and sand in the surface, mechanical surface polish.
Yep.
When it comes to, I'm assuming that there's going to be a difference in our go-to or our preference for a densifier in those two scenarios.
Yep.
Because it would seem to me that the surface polish is going to be a very different material. Can you?
Yeah, well, we talked already about before how the surface is made up of a lot of fine particles that have been highly compacted together if it's been properly troweled. Okay. So the thing that's coming to mind is essentially the way in for a liquid or a surface treatment product is going to be facilitated very differently, or it's going to be a harder job to get something in to the surface polish than it is to, say, a slab where it's been taken to an exposed.
I'd imagine.
And for a few different reasons, because when we go deeper into the concrete, and when I say deeper, we're talking, past that sort of top 5 mil, we have a more porous material to work with. So in that sense, it's going to be much easier to get something to penetrate into the concrete or be absorbed by the concrete. The scratch profile means there's a higher surface area to which a material can actually enter into the concrete. So if we're putting a densifier in at like a 50 metal or 120 metal or something like that, the surface area, if the corrugation, that scratch pattern's like a crinkle cut chip, that's a very high amount of surface area and entry points for a chemical to be able to get into the concrete. Most of the guys that are doing a surface polish, they might be starting at a 200 sort of resin or wet resin or something like that. So it's a much finer, much lower surface area, even in that cells, for a chemical to get in. Okay. So even the surfaces that a chemical can actually get into from a scratch profile point of view is very different, let alone the fact that the particles are far more compact, so they're going to try and get a chemical to penetrate in a surface polish, than when they're trying to get something into an exposed ag where there's air bubbles, where there's more porosity, where so the ingress or the ability to penetrate is very different in both scenarios.
Okay, so does that then mean, because there's the material that we need to densify needs to react with in either scenario is still going to be the same particle, right?
Yes.
And there's a whole lot more of that available in a surface polish than there is in a exposed aggregate. I mean, 50% is taken up by stone in the exposed aggregate.
Yep.
So, would it be right of me to assume then that a surface polish is a much harder and more durable surface?
Kind of. It sounds like it stands to reason. It sounds like all the materials, all the particles that you want your densifier reacting with, there's going to be a higher quantity of them in a surface polish, and there probably is.
Mm-hmm.
But I would argue that I'd much rather, as a comparative, so where we're densifying, we're dealing with the fines in the concrete, right?
Yep.
I guess the premise I would say is that the fines are never going to be as hard as the aggregate, right? So there may be more available material for the reaction, but you're taking the secondary part of the concrete, the fines, the least hard compared to the aggregate, and you're trying to turn that into the hardest possible thing you can. Chemically, but comparatively speaking, it's still softer than most of the aggregates that are used in concrete. Maybe Florida's a bit different, but certainly, when you've got hard granites and basalts and things like that are concrete's there for its structural property. Let's remember that. We talked about terrazzo earlier. That's there for its decorative element. Hence, they're using limestones and marbles and softer materials. It's not there for a structural component.
Mm-hmm.
Concrete is always used primarily for a structural function. Again, structure governs function, okay? We're using concrete slab for its hardness, its durability. So we're putting structural grade aggregates in it to achieve that. So you've got a bunch of your surface being made up, comprised of this aggregate that's really hard and durable. And next to it's this sand and cement and fine stuff that, comparatively speaking, we're trying to make the best that we possibly can out of that, but it's still not going to be as hard and durable and stain resistant, wear resistant, all those kinds of things as that chunk or that piece of stone that's sitting embedded right into it.
So you're telling me that a surface polish, you're making a claim that a mechanical surface polish is not as resistant to abrasion as an exposed aggregate mechanical polish?
I wouldn't say I'm making a claim.
I think we're
just following a train of thought here, and it seems like that would be a logical conclusion based on, at least on the sorts of properties and factors we've been talking about, that the surface polish is just, you're starting behind the eight ball from the beginning when it comes to getting the piece of material as durable and resistant to things like traffic and stain and so forth and wear as a fully exposed piece of material.
I can't believe it. I've heard claims of up to 400 times harder once densified.
Once densified? Yeah, it could be. It could be. But compared to the exposed aggregate, you're talking about if your surface polish is a 10, or let's just say, hypothetically speaking, your cream or your surface material in a surface polish is a 10, right? Yep. You could do that 400 times harder through chemical treatment. Let's just say 400 for the sake of the argument, and you end up with a 40, right?
Yes.
But if you're if what we're saying is true, that your exposed aggregate is a harder material to start with, and let's just say even if it's only twice as hard, right? You're still going to get the 400% increase there, because you're still treating it with the same chemicals and so forth. So now you're at an 80, right, as opposed to a 40. So it's still twice the durability, or twice as strong. So they both come up, right? So I'm not arguing with the 400 times improved through chemical treatment. I'm just saying they're not at the same base starting position to begin with.
Yeah, and I guess that's kind of evidenced by any type of weathered concrete that you see, particularly externally, or you see that it's worn because the sand cement particles have washed away or worn away, and it's the aggregates that are there, holding up the fort.
And that's where it stops wearing to.
Yeah,
because that's now we got 50% of your material being comprised of a nice hard compound like a structural aggregate.
It nearly sounds like I'm getting better value for money doing a exposed aggregate mechanical polish. Just saying. Well, that's really interesting. That's a lot of information to digest there. And these are obviously both going to be highly dependent on how you create each of those finishes, I'm assuming.
Yep.
Without going into heaps of depth, what are, I guess, in either of those scenarios, what are probably the most, important steps that you must follow in either system to ensure the longest term longevity? Is there anything you can skip?
Is there anything you can skip from a longevity point of view?
Building a durable floor.
Well, if we talk about your eroded concrete surface analogy or observation before, we're basically saying that as soon as you start getting stone comprising part of your surface, we can rely more on that and less on the fines. Okay, so I guess in theory, we could rely less on chemicals once we've got to in an exposed aggregate scenario, because we're just going to be leaning and relying on the predominantly much stronger component of that concrete being the aggregate. Whereas in the surface polish, we've got to do as much as we possibly can with the chemicals, because nothing's changing. It's all fine materials.
Yeah, right. Yeah, our chemical formula's got to be dialed right in.
Yeah, that's where we stand to get the biggest gain. Is somehow altering that top cream layer of the concrete.
Okay. So that in a surface polish, I guess the most popular densifier material that you see being applied there is a lithium.
Yep.
And why is that?
Well, it comes back to what we were talking about before. Lithium is a more highly penetrating molecule, lithium densifiers or lithium silicates, than the potassiums are. So if we've got a really highly compacted surface because of all those little fine particles, the channels or the for entry are much smaller. And we talked about that texture as well from the actual diamond tooling side of things. We need something that is going to be able to penetrate and permeate into that concrete a whole lot better, and not just sit on the surface and be taken off with the next step.
Yeah, I mean, and we also know that it's a whole lot more vital in the I would say the first installation of that floor, as opposed to coming back and redoing it at a later date, like reinstating a floor. That first exposure or application of densifier is going to be the most vital to a surface polish the first time it was converted into a wearing durable surface, as opposed to if we don't do it right the first time, our second opportunity at it is probably not as great.
No, and even if you look at in the one installation process, the further you get into the process and you're trying to get densifier in it, the harder it becomes.
So you become less successful.
Not the harder the service, the more difficult it becomes to get it in. Okay.
Yeah. So a lower success rate the further up you go.
Correct. The more advanced you become in the process, the lower the success rate of being able to achieve that is. So yes.
And so how would you know? What are some of the telltales Are there any? Because I can't tell the difference between a densified floor and a non-densified floor.
Well, you're pretty good on the practical side of things, Josh. You've been involved in a lot of training and training seminars in the past.
How's that for a handball?
Look, I think there's two elements to it. There's you want to get densifier in as late in the process as you can, but clearly you are trying as hard. You're trying to put. You don't want to create build-up in the process, okay? So there's a reluctance to go too heavy, trying to put too much material in, because you can create other problems when it comes to the actual polishing process, whether you're just polishing densifier, residual densifier, or you're getting densifier that's creating temperature and creating scratches and so forth. So even the practice or the technique of polishing a floor is a bit of a trade-off between trying to get densifier in late, but not too much, because of some of the problems that it can create. So at the very front end, the very first application, like you're saying, I agree, that is the most important one. One, because it's harder to do it later on, and two is contractors become more and more weary of putting densifier or introducing densifier into the process because of some of the other complications that can actually bring into the polishing process and from a tooling
perspective. Yep. Gotcha. Some of the limitations.
Yep. So if we were doing the best thing for the concrete, we'd just be dumping densifier on that as much as we could any time we can to get the best possible outcome from a durability and wear resistance. But we have a few other things that we need to be taking into consideration from a tooling point of view and the application point of view.
Doesn't sound easy to be a contractor. I mean, we refer to contractors as manufacturers, and it's really for that reason, isn't it? Because you got two different systems on the same slab, and you need to know the ins and outs of the materials on, even though it's the same materials, at the two different levels.
Yep.
And how to work with those to get the best end result. And that's always going to be also, you've got that, and then you've got the balancing act of the client's budget as well. So where is it safe to remove cost while the expectation of the customer is what I'm getting is still going to be the most durable floor I could possibly get. But that's going to have also some limitations to it too.
Well, one of the limitations is the client's looking at going, concrete, right? We've just been talking about the concrete effectively being two different products or two different materials. As far as they're concerned, concrete's concrete.
Yeah.
Both of them feel just as hard when you fall over them and knock your head on it, right?
Well, I think the Australian concrete is actually harder. That's why helmets are compulsory.
On building sites?
On bicycles and building sites, because it's much harder when you hit it. I'm pretty sure that's the reason why. So I think we've really addressed the contractor side of it, the making of the two different finishes quite a bit. There's one other element that I wanted to talk about, which was the sealer, but I think I want to talk about the owner side of the equation first, and then come back to the sealer side, because I think that it's probably going to answer some of our questions in that. So now I'm putting on my owner hat, and I've got a section of my building which was all the same pour of concrete, and we've got this scenario where we've got the deep aggregate exposure MPC, and then we've got the surface polish CSPC. Now they are aesthetically different, both beautiful finishes, beautiful floors, and now it comes to, I'm going to maintain these floors.
Yeah.
Am I going to notice any difference? I mean, it's the same concrete. Is there going to be any difference from a longevity? I think we've already kind of struck on that a bit, that the exposed aggregate is probably going to be more durable.
Yep.
From a maintaining those two surfaces, am I likely to notice much of a difference? They're both in this scenario high gloss finishes, both taken up to 1500 grit.
Mm-hmm.
How am I supposed to approach these two finishes?
I'm going to answer that because we'll put the sealer issue aside for a second.
Correct.
We're going to assume they're both sealed the same way.
Yep.
And with the context of this conversation, given predominantly in our marketplace and predominantly our experience has been an impregnating sealer, so a sealer that actually penetrates into the concrete and reacts in the concrete, what some people call these invisible sealers, as opposed to what we see a lot more in the Northern Hemisphere, these guards or these sort of microfilm, acrylic type burnishable plastic layers, okay? Because a sealer makes a big difference in this case in answering this question. But in the context of we're using an impregnating sealer, I'm going to say the expectation needs to be very different.
Why is that?
Well, the reason is going to come back to part of our early conversation, and that is in a surface polish application, we've brought a whole lot of fine materials to the surface, and we already established earlier on that those fine materials are in that concrete more for their reactive properties than for their, let's call it their structural strength and durability properties. So they're more chemically reactive by nature, which means that when I'm going to spill something onto that surface, whether it be slightly acidic based or slightly alkaline based, and I'm talking about a chemical reaction here, I'm not talking about just something seeping in and staining from a colour point of view, but I think most of the issues, a lot of the issues we deal with are more from a, let's call it a chemical reaction level.
Not just a contaminant.
Not just a contaminant, yep. Because we've got a surface that's comprised of particles that are in the concrete for their reactive properties, I think it's a pretty safe assumption to say that surface is a far more reactive surface than one where we've taken most of those particles away and we're dealing with 50% aggregate comprising of the surface, which we mentioned before are not very reactive materials, and then 50% of sands and other fine particles. So if we've got a highly reactive surface, we can assume that when that comes into contact with something that is slightly reactive in its own right, think of general household products, vinegar and tomato sauce or ketchup and
Earth Choice cleaning, floor cleaning product.
Let's talk about the actual maintenance products as well. But any time that that floor is going to come into contact with an acidic or alkaline type base product, there's going to be a higher chance it's going to react than a exposed aggregate product.
It's already super reactive by comparison.
Correct. And we're talking about an impregnating sealer, which do not create topical films or some sort of mechanical barrier. What an impregnator does is it creates a repelling action, right? So it doesn't separate the reactive material that's being dropped on the floor or applied to the floor or spilled on the floor with the reactive surface of the actual floor itself, the concrete, okay? So given the right or the wrong scenario, those guys can get it on together and have some sort of reaction. And what that's going to do is appear aesthetically as there's been a change in the look of the surface. Okay.
Yeah.
Because it's very unlikely and very rare that you'll have a reaction that doesn't create some sort of change to the surface of the concrete.
And that can happen. That can happen like at the extreme scenario here is spilling something, lemon juice on it or wine, tomato sauce.
Yep.
That's an extreme case. And I think everyone goes, oh, yeah, that's not a good idea. But how about just, like really watered down cleaning chemicals? Like repeatedly. I mean, someone who's looking after that floor. I mean, I love these two finishes. I'm going to mop this thing twice a week. Is this a good idea, bad idea? Things to consider.
with the right product, it shouldn't be a problem. And I think, look, what makes, I think, the whole surface polish thing really difficult, even to try and work out what's going on when we start talking about staining or etching and those sorts of things. We've already talked about how hard it is to get products into the surface. It's really hard to know how well the actual chemicals, the densifiers and so forth that were applied at the beginning are actually doing their job.
Reactive.
Right? We're just assuming everyone's sort of put the same amount of densifiers into their floor, but some people are going, like, I just couldn't get any more densifier into this floor, and some people are going, well, I didn't want to put too much on because I didn't want to cause problems for my tooling and so forth, right? So even just looking at it, we know that there's going to be
so many variables already.
A big variation potentially on how they've been set up. We know how much easier it is to get densifiers and chemicals into an exposed aggregate finish because you're doing it a whole lot earlier in the process. There's a lot of texture. There's a lot to be done after it. So any excess material is pretty easy to remove, right? It doesn't really interrupt or affect the difficulty of the process. So, we can assume that there's a lot more sort of almost blasé application of products in a exposed ag finish than a surface polish, where the contractors are generally far more hesitant or in the way that they're applying these things. So it just means that the finished product can be really, really variable with regards to its stain resistance, it's how chemically balanced or non-reactive it is, all those sorts of things. How porous it is.
All right. So again, it comes back to we really need to know all of the key the key areas of importance. How to set up the floor for I guess the best likelihood of success, not just in the application of we did this process and it looked shiny when we left.
Yep.
We're still talking about the shiny scenario. It looked shiny when we left and we got paid, and that's what success looks like. But it might go a bit further than that. Like, you're hoping that goes 12 months. But we've seen a lot of scenarios where that beautiful surface didn't last 12 months. And it's normally, it's in most cases that we've seen, it's nothing to do with people abusing the surface. It's actually the opposite, where they really tried to take good care of it and then they lost their surface effectively. It's like, oh, we spilled a whole bunch of vinegar or lemon over here. I got the mop and bucket. I sweeped it up into the bucket and thought, well, I've got the mop and bucket out. I'll just go mop and bucket the rest of the floor, but you still got all the lemon or vinegar sitting in that wash water. Yep. You've just spread it over the whole floor now, and it's a super reactive surface in the scenario of a surface polish.
Yep.
And now you've just hurt the whole surface uniformly. We've seen that scenario play out before.
Yep.
But even just general care and cleaning, need to be very specific about how you're doing that. Because you've got a super reactive surface. All right, so I think we've kind of done those two scenarios to death. I want to talk about now. I've got a surface. The same two surfaces, but the client says, you know what, I don't want a glossy finish. I want to go for a matte. So effectively, we're probably finishing that somewhere around about a 100 or 200 grit. Let's say that we've found that the process that suits us best is going to be to finish it with 100 HD tempo, right? That seems to deliver on a nice matte finish that they like. Now, there's two different ways to get to this finish. We can either go through the process, hone the surface, densify it, and then do a 50 grit resin, densify again, and then do a 100 grit resin and then finish off with a 100 grit HD tempo.
Mm-hmm.
The other way of doing that is to do a standard process all the way up to like an 800 grit and then knock off the gloss effectively by scuffing the surface with that 100x HD tempo. From obviously there's a big cost difference for installation there, but from a longevity, is there going to be any difference in lifespan that the owner is going to notice, and why?
My expectation would be your second scenario is going to be better.
Because?
Well, okay. One of the assumptions I'm making is that through those additional steps that are being done, there's still going to be more densifier applied to the floor. So there'll probably still be multiple lick coats, at least two, applied by the installer to the concrete after that sort of 100 finishing point that you were talking about in the first scenario.
Yep.
So we're talking about putting more densifier into the concrete. And let's face it, if you were going to look at how much densifier goes into a surface polish compared to how much densifier goes into an exposed aggregate floor, if you actually went through the exercise of looking at the volume difference, it'd be pretty stark.
Yeah, absolutely.
Be pretty stark. So we've already sort of addressed that the exposed aggregate floor is going to be more superior from a durability and wear point of view because of certain things. One of them is how much densifier you get into it.
Well, and when you're calculating the difference between the densifiers, the aggregate's not even taking any of that in.
Correct. That's
so
right.
You've got double the amount going into
half the space, basically. Yeah. Yep. So that is a really important point. So the assumption, the presumption, or the conclusion that you want to draw from that is that the more densifier you get into a concrete, the better it is. And I would say, in generally speaking, that is definitely the case. And secondarily, that we've already established that there's far less densifier being consumed or, infused into a surface polish. So the more that's done, the better it is. It's still going to be probably considerably behind what you'd use in a exposed aggregate. So the more you get in, the better it is, okay? Even though you're still a long way behind what you do in an exposed ag. So those extra steps to take it up to, say, an 800 and then pull back is going to ensure that there's and enable you to put more densifier into the material. And you can do that because you're basically adding more diamond tooling steps, which are creating friction and temperature, which accelerates and makes reactions complete. So you will get a better result, not just from extra densifier, but you're actually adding one of the elements to a chemical reaction or that improves chemical reactions with temperature. So you've done that at least 2 times to the floor than in the 100 finish case. So one of the main things is that extra application of chemicals that you're getting into the floor that you wouldn't be in your first one. So we want that. And secondly, you've profiled the floor up to a lot better level. So we talked before about a scratch essentially being like a crinkle cut chip or crisp. And the bigger the corrugations, the more surface area there is for things to enter or react with the concrete. If you're taking it up to an 800, those corrugations become much smaller, okay? And even though you're pulling it back with the 100, you're going to end up with a different surface profile. You're going to have probably much bigger spaces between your corrugations than in the first case.
And they'll have less of a curve to them.
Yes.
Or a larger curve rather. So
yes, they'll be a rounder.
So when it comes to a contaminant entering, they've got less of a chance.
There's essentially less surface area. So you can't look at a floor as in 50 square metres is 50 square metres is 50 square metres. I mean, that 50 square metre floor with a 30 metal could be 150 square metres in available surface area, if you want to call it that, compared to when it's taken to a 1500 or something like that. It's pretty close to 50 square metres of available surface area. So it's 30% or 1/3 of what it was at a 30 grit. that's just me plucking some arbitrary values, but it's the principle that's important here.
Yeah. Have you ever tried real estate? I reckon you could sell.
Well, this factory used to be 300 square meters, but then we ran a 30 grit diamond over it. Now you've got
600. This is good.
So see how much we can add to the industry as concrete grinding professionals. We can create upside for everybody, not just happiness over beautiful looking floors. We can create extra space.
We're charging more for low grits, for low grit floors now. Well, that's a ton of info. It all makes sense.
Mm-hmm.
I had some other questions. I think that you've really answered those two scenarios, whether it's a deep aggregate exposure, satin or matte finish versus the surface polish. I think I can see how that would affect the finish. And we talk about trying to, I guess, make the least reactive floor for longevity with the surface polish, and that setting up is even more vital.
Yep.
If you want to create a long-lasting floor. Thank you for that. The other thing that I wanted to then talk about is we've talked about these really reactive surfaces. We've talked about impregnating sealers. Is there a different solution for that? How do we go, all right, well, we've created a surface polish. It's 50 times more reactive than the exposed aggregate, and we want it to be even more durable than an impregnating sealer. Can I just layer up more coats of impregnating sealer? Is that going to give me the extra protection?
Well, in a sense, yes, it would, because you'll get to a point where the floor is not really taking any more sealer. It starts to build up on the surface, and there's always most of these impregnators. Certainly, our one has some waxes and so forth. Okay, you get a bit of a waxy layer on the top of the surface that's not removed. You've kind of got a topical barrier for a period of time having that sort of a waxy layer if it's not all being burnished off properly. But generally speaking, no. More and more sealer isn't going to give more and more durability. Maybe more sealer more frequently, or with shorter times, time spans between it. And I'm talking, 6 months compared to 5 years of like a reapplication or a retreatment. Because all these things do is change the surface tension in the concrete, okay, to repel or reject or resist. So more frequent application as opposed to more volume of application is probably more your better friend. But generally speaking, because they're an impregnator and they're not creating a separation or a mechanical barrier, it's not going to offer. It's not removing or changing the dynamic, which is two materials or two reagents being able to come together and have a reaction. We talked about parking that sealer issue before, but if we just bring that topical sealer back into the equation, okay, we talked about that in the terrazzo days. We talked about that being a much bigger thing in the United States, and I can understand why it's such a big thing in the States, because so much of their market is this surface polish finish. Okay, the Australian market developed in that decorative exposed, and the whole process and the whole sort of contractor experience and all the specifications for many years have been oriented around that type of finish, and that brings its own challenges and considerations that need to come with that. You go to the Northern Hemisphere in the States where it's so much more large format retail, surface polish. They've been dealing with this type of material, if you want to call it, for much longer than we have in the Australian marketplace. So it makes perfect sense to me that they've seen some of the pitfalls, and this is why so many of these guards are going down these acrylic microfilm coatings, because that's kind of the best alternative to our grind and seal that we were talking about in the beginning. You can still get a nice, smooth, profiled, polished-looking surface without all the roller marks and texture from a roller. Okay,
and the solvents.
Yeah, but you're creating a mechanical barrier, albeit a very small and thin one, and it's only good for certain types of reagents or contaminants. Okay, that will at least create a little bit of a mechanical barrier and minimize or reduce the ability of those contaminants being able to react with that top reactive surface of the concrete. I mean, once they wear off, of course, there's nothing there at all.
Yep.
Which is the great thing about an impregnator. They generally last a lot longer and will continue that sort of changed surface tension state of the concrete to give it repelling and rejection.
So even if the very top is compromised by like a stain or so, it's going to maintain that at the top level. Whereas I guess if you've got a mechanical layer that's removed or gone, it's basically just free game.
Yeah. So the whole concept behind the benefit of an impregnating sealer is that they are designed not to eliminate the effect of a contaminant or a reagent because there's no mechanical barrier. But what they do is they keep it close to the surface. They tend to limit how far it can penetrate into the surface of the concrete. So if you're talking about a colorant type contaminant where it stains the floor, I'd rather that sort of stay in the top 0.5 to 1 millimetre of the concrete than penetrates 5 millimetres in. Because from a repair point of view, I can repair that and still have
much more superficial.
A surface polish looking. I'm not breaking through all those fines to get it all out. Whereas if it's 5 mil deep now, for me to get rid of that, I'm going to have an exposed or a semi-exposed patch of concrete with aggregates showing through because I've had to grind down deeply to get that out. So they have their pros and cons. They both have their maintenance considerations and implications, and that's all part of the decision-making matrix that has got to be put to a client or that's got to be weighed up by a contractor.
Yeah, gotcha. Tough decisions. Well, while we wait to make that decision, I'm really happy with how it's all come out. Now, I just want to also...
You're talking about the floor.
The floor?
Yeah,
wait.
Not the contents of this conversation.
No, not the contents of this conversation, but, I think the floors have both come out very well and I'm yet to make a decision. I think I'm going to go down that impregnating sealer route. But while I make a decision, we've got a couple of weeks before my new dwelling here is going to be handed over. In the meantime, and I just want to point out that this podcast is not sponsored by any floor covering systems or floor protection systems. So, Tim, I'll ask the question. What is your favorite floor covering product to protect my newly installed mechanically polished concrete, either exposed aggregate or surface polish? What's your favorite? What's your go-to?
Probably a layer of dust.
Okay. Can you mind elaborating on that? You can speak freely. We're not sponsored by anyone.
We're not taking money from anyone today.
No.
No floor covering whatsoever.
No protection.
No. I would, like I said, I'd prefer just a layer of dust. If the plasterer or someone's going to drop something in the floor and it just hits a layer of dust on the floor of some sort, that's going to be quite easy to take off and remove.
Okay. Can you tell me why you don't want to cover the floor?
Pretty much for every floor covering, whether it be obviously polythene plastic or underfelt or carpet or these types of cardboard or high density sort of whatever they are, compressed cardboard products. Every single one of them, well, with the exception of say a carpet or an underlay, will restrict the moisture migration through the concrete and trap it at the surface underneath. I don't like carpets and so forth for many reasons, but they hold and retain water, and they hold and retain a lot of fine particles that can really scratch and be, sort of ground into the surface through traffic and so forth. So they're pretty horrible things, particularly when there's water spills and whatnot. Plastic obviously just does not let any air permeate through it. And if you get a lot of condensation built up underneath of it, and of course, if there is a water leak or something, that water finds its way underneath the plastic through an overlap or a joint or a hole in it, and it's trapped under there for weeks, just sitting latent there on the top of the surface. And the same thing even with these, these compressed cardboard or whatever they're called. They just restrict the ability of moisture to move through the concrete into the air, but they can also entrap moisture and water underneath of them if there's water spills and so forth. And of course, no one knows what's going underneath. People might spill something and the top dries out and they think everything looks good, but if it's got an underneath of it, it's going to take a lot longer for it to dry out and come through. And whenever you have water and moisture and so forth sitting under these things, we've talked about the reactivity of the surface of this surface polish, and even in mechanical exposed aggregate, moisture sitting there on the surface and not being allowed to do its thing ends up having an impact and deteriorating the surface of the concrete.
Yeah, and particularly in the scenario of a new build.
Yep.
There's so much happening still with that concrete. As you get to lock up and all that sort of stuff, completely changes the air pressures and the environment. And then it's always going to be, we've got to get this done before Christmas, so we've got to put the garden in as well. So everyone's working there, and we put the garden in. We don't moisture barrier the slab against the newly established garden beds, which actually need a whole lot of extra water to get the garden to take. So now we've got pumping tons and tons of water into those beds, and you've got the sun beaming in through the windows, these beautiful new big windows, and creating a lot of heat on the concrete, and it's just sucking every bit of moisture out of the garden beds, and it can't go anywhere.
So we're not even talking a lot of the case of moisture that's coming out of the curing of the actual concrete.
It's all environmental stuff.
It's all the surrounding landscapes and so forth.
Well, plenty to think about.
There is a lot. And I guess the main takeaway is that there are significant differences between these two finishes. And we'll take it the step further and calling them two different products, I think, as the outcome of this conversation. They're not just finishes, they're two different products for all the different things that we've been talking about. And they need to be considered that way because all the expectations and the communications and the sell process has to be framed around that. Because if we're leading a client down the pathway of it's concrete, then someone's going to end up disappointed, and someone's probably going to end up doing a whole lot more work than they actually intended to do.
Yeah, at some point they're not going to be able to blame it on the concreter anymore.
Correct.
Lucky guys. Finally getting off the hook.
What looked like a process that had a whole lot less work involved in it, less steps, the surface polish, ended up becoming a whole lot more work because I had to keep going back and fixing that because I didn't tell the client the differences between their choices.
It's not just aesthetic. It's not just aesthetic. And it requires a significant amount of knowledge and know-how and tests and measures along the way to ensure that you're getting the best outcome. And even from there on out, it's not just concrete. And if they've lived on an exposed aggregate MPC before, they're probably dealing with a different beast.
Correct.
They need to know the pros and cons when making the choice, and then even on delivery. Well, there's a whole lot in there, Tim. I feel like we're in the top layer.
That top 5%.
And I actually probably feel a bit dense now too. Just the same. Thank you so much for giving up your time coming out of R&D. It
was my day off today, actually, Josh.
It was your day off.
I just do this for fun. No, I just knew how long this conversation could have gone for, so I scheduled on a day of annual leave just to make sure I didn't have the expectation I was going to get some work done today as well.
Well, I believe that once Brittany's done with the editing, she promises we'll be able to get down to about 2 hours. So
The amount of work left I can do today, is that what you're talking about?
That's just status quo for you. Well, thank you so much. I think our audience is probably going to learn a lot from that. I have.
Wake up, guys. Wake up.
I have. And yeah, if we have put you to sleep, let us know in the comments when you wake up. Which part did you fall asleep? We want to know how effective this is on the podcast. Again, thank you for your time. Guys, continue to give us your feedback and tell us more about what you want to hear. And again, thank you for listening, Tim.
It's been fun as always, Josh.
It is always fun.
Talking about the greatest product in the world. I mean, who wouldn't want to do that?
Concrete. All right. Thank you.
This show is proudly supported by WorksPlus. WorksPlus brings total solutions to all concrete grinding and polishing contractors to make it totally work for their daily operations. We hope you've enjoyed this show. Make sure to tune in each week where we're going to dive deep into all things related to concrete grinding and polishing. We're here to help you so that you can boost your outcomes on the floor.